Dear all, hello. I think it's time. We're really sorry for the delay today. I'm Stratis Karadanelis. I am the chair of the group of young engineering geologists of IAG, and we would like to invite you to the 10th series of e-YEG webinars with invited presentations from Dr. Alessandra Cristi Corsi and Ms. Aline Freitas da Silva from Brazil. We will start with Professor Corsi. I will provide a small introduction. She will provide us with a presentation on geological and geotechnical process in Brazil, types and map methods. Dr. Alessandra Cristina Corsi has a bachelor degree in geology from Universidade Estadual Paulista, a master degree and a PhD degree in geosciences and environment from Paulista State University. She works as a researcher in the Investigations, Risk and Environmental Management section of the city's Infrastructure and Environmental Area Institute for Technological Research of the state of Sao Paulo. She serves as a professor at IPT's Professional Master in the Specialization course Subsoil Investigation, Geotechnics and Environment. In 2004, she attended the 5th International Course, Management of International Systems for Disaster Mitigations, offered by the Japan International Cooperation Agency. In 2010, she participated in the program for training abroad through the US Geological Survey. She has experience in geosciences with emphasis on geographical information systems and geotechnical cartography, working mainly on geological hazards, mapping and management of risk areas, surface dynamics processes, geoprocessing, and geostatistics. Professor Corsi, we are really thankful for being here today. So please share your screen and the space is yours for your presentation.
Thanks, Strat. I'll share my screen right now. Did you can see my screen?
Yes, you can see your screen.
Good. And hello, everyone. Thank you, Strat, International Association for Engineering Geology and Environmental, and the Young Engineering Geologists Group, also the Brazilian Association for Geological and Engineer and Environmental, for this very kind invitation to present this webinar. Today, I will be talking about the geological process in Brazil, types and mapping methods. Sorry. I divided this presentation into 4 topics. The introduction, I will talk about a little bit from Brazil, and we go to the types of most frequently geological geotechnical process in Brazil. I divided these talks into the 5 regions you have here in Brazil. Then you go to the mapping methods used here, and finally the final considerations. Well, Brazil is located in the South America and have an area of 8,510,000,000 square kilometers, and 84.7% of our population lives in urban area. Here are our 5 regions: the North regions, Northeast region, Middle East region, Southeast region, and South region. Well, now I present the geological Brazilian map. In the yellow, we can see sedimentary units. In the north, you can see a huge area with sedimentary rocks associated to the Amazonas River Basin. In the red, we have magmatic units. In pink, metamorphic rocks. And in green, volcanic rocks in the south and the middle east of Brazil. These units have influential direct in our geomorphological map. And in the north, you can see a huge basin, is the Amazon basin. And in the south and southeast Brazil, you have mountains relief. And in the pictures in the top of the right, you can see the Amazonas River Basin with a flat areas. In the in the right, you have also a schematic model of the São Paulo relief. We can see the height of our mountains, this difference from the coastal to the other parts of the state. Also, we produce Brazilian maps from susceptibilities. In the left, you have a landslide susceptibility map. In the right, we have the erosion susceptibility map. In the case of our landslide susceptibility map, you can see in this picture, in the red color, the high susceptibility areas that is concentrated more in the south and southeast of Brazil. And in the right, you can see the same way to the erosion process. Here I show a chart with depths by landslide or mass movements. This database is developed by the IPT. We have a research here in IPT called Eduardo Macedo. He developed this data. We have data from 1998 until now. The depths occurred by landslide debris flows. You can see in this picture that the regions with more depths are concentrated in the southeast of Brazil, in the states of Rio de Janeiro, São Paulo, Minas Gerais, Santa Catarina, Pernambuco e Bahia. In the case of the Rio de Janeiro, the depths are mostly associated to the debris flows occurrence in 2011. Because our economic and social conditions of the last decades, there has been an increase in the number of people living in landslide and flood risk areas in Brazil. In this picture, you can see the vulnerability of the houses. You can see wood houses, very, very badly built. And in the top left picture, you can see this vulnerability in the bottom of the hill, and in the house building, bad building. And these situations is nowadays worse because the COVID pandemic, you have more people living in risk areas. Now let's move to the process. I select some most frequent processes in Brazil to present here. We have different processes in our regions. We will talk about landslide, debris flows, erosion, riverbank erosion, especially in the north of Brazil. They call it that with like Terras Caldas. So let's move to this process. I will start with the north region. The most frequent process you have here is riverbank erosion. And this process causes material and life loss. easy. In this map, I show the municipalities that have problems with river erosion. They are in green, and lateral erosion occurs on banks of Amazonian River with gravitational movements and is mainly related to large landslides can people who lives along this. Is a phenomenon similar to those that occur in mountainous regions in Brazil. Our Brazilian Geological Service mapped these municipalities to this process. Here I brought some examples. In this case, we have an example from Gametá County in Pará State. In the photo on the upper left, you have the houses near to the top of the riverbank slope that happened before. And in the picture at the bottom right, in the right, we see that the human interventions that try to protect this part of the city, but didn't solve the problem. The erosive process continues until here, another example, Iranduba County, Amazonas State, associated to Solimões River process. In the photo on the upper left, you can see the crack in the marginal riverbank. And on the upper right, there is steps on the riverbank. At the other two pictures, we can see very closer to the riverbank. Here, another example in an Indian community, São Francisco do Camimari, Marutá municipality in the Amazonas states, also associated to the process that occurred in the Solimões River banks. We can see the step here at the riverbank, and this material goes through the river. In this other picture, you can see the engineer work to protect the riverbank because you have several houses and stores at risk in this part of Parintins County in the Amazonas state. This process is associated to the flood. They occurred during the flood process when the water goes to the maximum capacity, and after the flood, return to the original position, and this process started in the type hydrostratigraphic process. It's a huge problem in affect toilets and caused several. Now we go to the northeast region, when you have the most common process is the landslide. The Pernambuco pictures here to the landslide. And here is an example in the Recife metropolitan region. In both pictures, we have landslides because the human intervention in the slope. In Brazil, have the tradition to live on flat areas. So on the slope, there are always cuts and fill. In both, here have depths, and you can see here the damage in the. Another example in the Recife metropolitan region. In this example, there was intense rain above 100 millimeters concentrated in a short period of time. The landslide occur mainly in sedimentary rocks of the Barreiras Formation. Now we go to the Bahia state. These examples are in the Salvador cities. You can see the houses on the top, middle, and the bottom of the slope. The landslide affected the houses located in the middle and at the bottom of this slope. You have a lot of risk areas in Salvador City, and nowadays they have a monitoring system, and they operated this plan for people during the rain time. Well, let's move to another region here in Brazil, in the Middle East of Brazil. We have three states in this region: Mato Grosso, Goiás, Mato Grosso do Sul. Both these states are famous here to be agricultural areas. And the most frequent process in these parts is the erosion. Well, all the types of erosion I will show here is gully. Here in all these examples, usually the process is associated to the concentrated water flow. In this photo in the left, the erosion affected a highway that connects the municipality of Anápolis to other parts of the state. In the second picture is in Aparecida de Goiânia County, in Goiás state also, and affected houses and the streets. Normally is because the water flow, and we have problems when we build our water systems here in Brazil, and this is one the causes of the erosion process in urban areas. Here we can see the gully that destroyed some houses in the left, and the other pictures in a rural area affect the agricultural land. In this example, the gully destroyed the street and put home nearby at risk. Now, we go to the southeast region. I live here in this region in São Paulo city. And the most frequently process you have here is associated to landslide, debris flows, and erosion. The mass movements in Brazil are a phenomenon that occurred since the first reports in the 18th century and caused various social, economic, and environmental damage. Well, I divided the landslide occurrences in natural slopes, show some examples. So in this slide, I show photos of the Anchieta Highway in Serra do Mar. Here we can see evidence of landslides through the scars on the slope. You can see this process here. This region is normally affected by landslide. Now another example in Serra do Mar Mountain in Cubatão County, São Paulo State in 1985. After these landslide events, the government, São Paulo State government, developed an innovative project for reforestation of the Serra do Mar in the Cubatão County. The city was then undergoing a strong process of environmental degradation. In this part, we have a lot of chemical industry, and the vegetation was degraded, and some institutions here in São Paulo together developed a process to revegetate forestation area with use the helicopter for that. Well, let's show some recent events directly related to the increase of the extreme events here in Brazil. In both of these processes, we have rain exceeded 200 millimeters. In the left, you can see pictures from the Rio de Janeiro state. The event occurred in January 2011. You can see a lot of landslide in the mountains. And in the right is an example from Guarujá City, São Paulo State, that occurred last year. You can see the scale of the landslide in a vegetated area. Now some examples in cut slope. Here, in this example, occurred in Campos do Jordão city, in São Paulo State, is a touristic city, but you have also favelas in that part. And normally, the population cut the slope and build their house. Normally, this slope, this cut, usually is a vertical slope, and the height of the slopes are higher than the houses, and we have intense rain. The process start affect a lot of houses. Here, both example in the Caratinga city of Minas Gerais states, also in cut slopes and damaged houses in the bottom of the slope. Here you can see, in this case, the damage of here in these houses. In this picture here, you can see the water pipes that launched water on the slope contribute to this event. Now, some examples of landslide in field slope. Here in the Santos County and another in the São Paulo city. Often when we building, people here building a house, they cut the soil they cut in the slope, they use it to make a landfill and thus expand the houses. Normally are poor compacted and built by the residents themselves. And when we have rain, the landslide occurred in this part, normally damage some parts of the house. Here in this picture, you can see the damage on the street, and here, these two examples, very close to the houses here in the top. Now, some examples of rock slide and rock fall. Here in the Espírito Santo state, the blocks of rocks rolling through the hill and impacted these houses here, destroyed someone's in this path. You can see here a metric block that impacted directly in the house. And here in a rural area, and affect only the street, affect only the road here. In this other example, is in Ilhabela County, São Paulo State, in the coastal area of the São Paulo State. In this picture, you can see a part of the block. The block rolled here. This is his path, broke, and part of this block is here, and the other part affects this house. A couple lived in this house, and the wife heard the noise and left the house with her husband. Now I show some events of debris flows you have here in the southeast region. In this table, we can see some events you have in Brazil. How you can see here, mostly of this event occurred in the southeast of Brazil, in the mountain area in Rio de Janeiro and São Paulo states. In São Paulo state, this process mainly occurred in the Serra do Mar region. Also, we have events in Santa Catarina and one in Ceará, in the Maranguape mountain areas. And the Paraná states also will have this process. The Caraguá debris flows occurred in 1967 and affected the Santo Antônio River basin and reached to the beach. How you can see here in this picture, you have tree trunks and mud in this part. In this part here. And in this event, we have more than 500 millimeters of rain during 3 days, according to several studies. Here, also another event in the Serra do Mar, in the Cubatão County, in 1985. And in this time, the Serra do Mar was degraded and a heavy rain triggered the shallow landslide. We can see a lot of scars here and here also. And here, the vegetation damage for the chemical pollution. Now, I brought one example on the Rio de Janeiro state in 1988, affect the urban area of Petrópolis city, destroyed houses, and the flow goes through the street. Here you can see the blocks that affect houses in this part of the city. This other example occurred in Rio das Pedras River Basin in the Cubatão County in 1994, affected the Presidente Bernardes refinery and destroyed parts of the refinery, and they need to stop for 10 days the Presidente Bernardes refinery and generate a loss of $44 million in revenue. In addition, they need to expend more $2 million in cleaner to the area of the refinery, and they, after this event, they building some protections, sabot barriers to protect the refinery. Other example in the Rio de Janeiro state, in Quitete River Basin, we can see a lot of landslides here in the mountain areas. They are vegetated areas and occurred in rural areas also. Now, other example, in the Post neighborhood in the Terras Caldas County in 2011. This process here caused damage and loss of life. Here it rained more than 200 millimeters. We can see my colleague here in this picture. And in this point, a house was completely destroyed. Sorry. In this point, a house is completely destroyed. You have a lot of houses here, very, very closer to the small drainage, and all the houses here was completely destroyed. Now we turn the top for the erosion. I brought some examples here. We can see the erosion in urban area. This occurred during 24 hours and completely destroyed part of this new land use. And this is in rural area. Also, you have this problem, damage agricultural land. Now we go to the south of Brazil, and the most frequently processed in this part are landslide and also debris flows. I show some pictures in the landslide in natural slope here, is in the Itajaí Valley, Santa Catarina state. These events occurred in 2008 and affect urban areas. And you have in this period concentrated rain between the days 21 and 24, and you have total rainfall between 500 millimeters and 600 millimeters in this valley, and affected rural areas. And here you can see some landslides here through this vegetated area. Here another examples. And here we have example in urban area in Blumenau City Here you have some examples in the urban area at Blumenau City. You can see here in this case, we have landslide in a cut slope, affect the houses here at the bottom. Some pictures of debris flows in this part of the country. Here you can see in Tibete do Sul in 1995, we have intense heavy rain above 500 millimeters. We can see a lot of the scars here in the hill. Is a natural area because they are part of the national park. Other examples in the Itajaí Valley, you can see the material here affecting the rural communities. And here in the Rio Grande do Sul state also, we can see the scars here in natural areas. Here, this event took place at the St. Hilary National Park in the Prata Mountains. Is important to highlight that you have problems to quantify the rain in those processes, because normally in these areas, they are rural areas and you don't have rain gauge to estimate the rain in this part of regions. Now, I will change a little bit the topic. I will show some example of coastal erosion. This is other problem you have here in Brazil, and affected 17 coastal states. And this erosion bring many consequences, not only the beaches, also to various natural, environmental, and anthropogenic activities. Here is in the Natal city, you can see the house completely damaged, completely not, the house damaged, and in the other pictures, you can see the infrastructure damage for the erosion process. Here, also in the Rio Grande do Norte state and Bahia state, affected the infrastructure in these areas. And here is in the south of Brazil, in Florianópolis city. You can see the house damage. And here in São Paulo and Rio de Janeiro state, also damaged houses and the infrastructure in these areas. In this picture in the right, you can see they try to protect this part, but the process continues until now. Now I will show some mapping methods you have here. Well, in Brazil, you have geotechnical maps produced first. The first works that produced this type of maps is the 16th, with more intense production during the 18th. In this example is the geotechnical map for Santos City. This map was developed by IPT, and the civil defense continues to use this map until now. And after the events that took place in Santa Catarina in 2008 and in Rio de Janeiro in 2011, Brazil developed the National Plan for Risk Management and Disaster Response, coordinated by the Casa Civil. And we have the law 12,608, that the law established the national civil defense and protection policies. And this law altered others law you have here, and one of this law is the Statute of Cities. This statute established this new paragraph in the law established that municipalities that had susceptibility areas for geological process or hydrological process that need to prepare their master plan. Now, previous on this law, only municipalities with more than 2,000 inhabitants should have the master plan. Also, altered the Lemon Law that established the rules for land subdivisions, and now municipalities that have susceptibility areas must have the geotechnical map of suitability for urbanization as a requirement to approve new land subdivisions. The municipalities need to have susceptibility map, geotechnical map of suitability for urbanizations, and the risk map. The methodology I will present here to susceptibility map was elaborated in 2002 2023 by IPT in a partnership with the Geological Survey of Brazil, CPRM. The methodology should be replicable for the entire national territory, and you have in this problems with the scale of the maps you have to produce this type of maps, and it's a challenge for us to develop this methodology, but we can do that. And here's some example. This susceptibility maps is also through hydrological process and mass movement process. In the red color, you have high susceptibility areas, in this case, for the São José dos Pinhais County in the Paraná state. In this other example is to Cubatão County in São Paulo state. You can see in the colors here, in this part, you have more higher susceptibility associated to the Serra do Mar. This other example is in Nova Veneza County, Santa Catarina state. We also have in these mountain areas more susceptibility to landslide, rock falls, and also debris flows. The geotechnical map of suitability for urbanization have the main objective to support the indication of urban areas suitable for urban uses and not yet occupied. It uses the urban spatial area defined in the master plan and need to consider the changes made by the type of occupation you have in that areas, and also need considers conservation units or other areas equally protected by law. They use a lot of information, susceptibility maps, risk maps, land use, geology, and slope. To prepare this type of maps, here, in this case, we have here the informations to expand the urban area. Here, some informations with the type of land use they could be in these parts. Here, other example. In this part, they can't occupy it. Now, this other example, this here you have a water reservoir and some protected areas in the red. They can't occupy this part because you have environmental law in this part. We also nowadays have a methodology for hazard maps. This methodology was developed in a partnership with the Japan International Cooperation Agency and was based on the morphometric parameters at the slope. It's a new product and you don't have a lot of maps prepared by this methodology. Here is one example prepared by the CPRM. In this part, you have a high hazard area, potential to be damaged for some events. And here I only highlighted the risk map methodology because Aline will talk about this in more detail. The risk maps need to present the distribution, type, and the degree of geological hazards, evaluated the potential damage due to the occupation arising from natural phenomena or induced by land use, and the methodology for risk mapping was developed in 2007 by the IPT together with the Minister of Cities and established the national methodology for mapping risk areas. Here, just one example. We here have the sectors with different degree of risk. In this case, we will have a sector with high, very high risk, and here also, and you have another problem here with a lot of garbage in the slope. Finally, some final considerations. In Brazil, we have different processes from north to south. The Amazon River Basin, we have a completely distinct phenomenon from the other parts of Brazil. We need more geological, geotechnical studies to the Terras Caldas and also to coastal erosion. And nowadays, because of our economic problems, we will have more risk areas in our country, unfortunately. Thanks you very much for your attention. I've put my mail address. If you want more information, send me a mail. Is that for now? Thank you very much.
Thank you very much, Professor Corsi. I think it was really interesting, the presentation, and a lot of people found it already satisfying. I think we have time for 2, 3 questions. So please, if you want also to pay look at that, just click on the chat. So I will start with the first question. Surprisingly, landslides and debris flows are, despite good green cover, appear to be a function of precipitation and erodibility. What is the lithology in the area?
Well, we have normally magmatic rocks, granite is the most common, but is related more to magmatic rocks. And also in the south of Brazil, we have volcanic rocks, basalt.
The second question is, the statistics find that most of the landslides, riverbank erosion, debris flow occurred in south and southeast Brazil. What is the main reason behind this? Population, precipitation, or geology?
And precipitation is also the main problem, but we have in urban area, the process of recoup the slopes is a very high problem because normally they cut and fill these parts, and is the areas not indicated to be occupied. But the rain is the principal factor.
The question is, all these natural occurrences becomes a hazard when human settlements are involved. How is the government responding to the information prepared in their plannings, and what are the responses from the developers, especially to the changes done to the development statuses?
Well, this is a complicated question, but no, our major problem is that the municipality don't have techniques, and geologists or engineers in their employees, and normally they don't understand correctly all the maps you have. Nowadays, in IPT, we are developed a project to work with the municipalities and train them to the use of these maps for better use. Is that, and I think you don't have any consequence to the government in this parts. I think so. I don't have any.
Any feedback, you mean?
Yeah.
Okay. I think it's time to thank you, Professor Corsi, for your presentation. We should move to our next presenter, which is Miss Aline Freitas da Silva. She will present on methods for mapping natural and anthropogenic geological geotechnical process in urban areas, Brazil, and risk management. A small introduction. Ms. Aline Freitas da Silva has a bachelor degree in geology from the State University of Rio de Janeiro, a master degree in geotechnics from the University of Sao Paulo. She's currently a PhD student in natural disasters at the Paulista State University. Since 2007, she has been part of the Center for Scientific Support in Disaster in Brazil. In 2011, she entered the public service as a geologist at the Rio de Janeiro Geological Survey, where she served as Director of Geology at this institution from 2015 to 2021. She was awarded with the Carlos Walter Marinho Campus Award by the Rio de Janeiro Geological Survey, with the Lawrence Dobereiner Award by the Brazilian Association of Engineering Geology in 2013, and with the Silver Hammer Medal by the Brazilian Geological Society in 2016. She participated in Laram School in 2010. She was also a GISA alumni in 2015 from Japan. She was president of the Rio de Janeiro branch of the Brazilian Association of Engineering Geology for 2014 to 2015 and 2016 to 2018. Not yet, Professor Ms. Alina de Freitas, we would like to welcome you to this webinar. The space is yours. Please share your presentation. And thank you very much for being here.
I appreciate this. I will share my screen. It's okay?
Yes, we can see your screen. Yeah.
Okay. Hello, everyone. First of all, I want to thank the International Association of Engineering Geology, to the young engineer geologists, and of course, I want to say thanks to Stratis for this kind invitation to participate in this webinar. It's an honor for me being here today and talking about this topic and share the Brazilian experience, but just a little bit. The title of my presentation is Methods for Mapping Natural and Anthropogenic Geological Geotechnical Process in Urban Areas in Brazil and Risk Management too. I brought here a kind of script of what I'm going to tell you in this presentation. First, I will show some photos of geological geotechnical process that we have here in Brazil to illustrate the issue and contextualize the problem. Then I will talk about risk management in Brazil, but just a glimpse, because I will focus on landslide risk mapping. And then I will talk in a detailed way of the most known and most used landslide risk mapping methodology that we have here in Brazil. And finally, I will show you some examples of these applications that is used by the 4 main agencies of mapping agents that we have here in Brazil. Let's go. Well, as you can see, it is a very old problem that we have. In this black-white photo on the left, we have accident that happened in Santos City.
São 11 horas.
Sorry about that, my computer. Santos City, that happened in 1928, very old. And the other black and white photo, it's from Rio de Janeiro City, that happened this accident happened in 1967. It was a very important disaster that we have here in Rio de Janeiro City. At the middle, we have an example from Petrópolis that happened. Petrópolis is a city located in mountains region in Rio de Janeiro state. It's a very famous city that we have here. So this accident happened in 1988. And at the bottom, we have example from Campo de Jordão city, which is also a mountains region, but from São Paulo state. That disaster happened in the year of 2000. Well, it's a old issue, but that's still happening. Well, as you can see, as you know, natural process, geological, geotechnical process will continue to happen because it's part of the natural evolution of the landscape. But as you can imagine, many times when we have these accidents, we have many fatalities too. This is a very sad part. I bring here more examples from Rio de Janeiro state because it is where I have more contacts and have more experience. Very recent example, it's from Santo Antônio de Pádua that happened in this year, the beginning of this year. But we have also other examples from another states in Brazil, such as Salvador, that happened in 2015. And another recent example, it's from Santos, located in São Paulo state, that happened last year. And we have mass movement in natural areas as well. Alessandra showed some examples in her presentation. I brought these 5 examples here. In 1967, we have 2 disasters in different cities, in Caraguatatuba, in São Paulo, and in Serra das Araras, in Rio de Janeiro state. At the bottom, we have an example from Cubatão in 1985, Timbé do Sul. It's a city located in Santa Catarina state that happened in 1995. And the most recent example that I brought is from Rio do Sul city that happened. It is a city located in Santa Catarina state too, that happened in 2020, last year. About Santa Catarina, I brought this disaster. First, just a comment. This disaster, it was very important to me because it was my first emergency mission. I worked there with the SENACID team. SENACID is the Scientific Support Center for Disasters. It is a group of volunteers, a group of specialists in disasters. We work at this response stage of the disasters. About these events, all this red region highlighted in red in this map was severely hit by floods and mass movements, landslides. It rained 8 days non-stop. It was recorded more or less 1,000 millimeters of rain. And because of that, many counties get in an emergency or public calamity situation. Sadly, we had 135 fatalities, more or less 8,000 people get homeless, and near to 10,000 buildings, homes was directly affected or destroyed by these disasters. After that, the other major disaster that we have in Brazil happened in Rio de Janeiro state, in the mountains region, and happened in 2011. Well, the pluviometer network, the rain gauges network at the time was not so good as we have now, but it was the official data that we have says that rained 241 millimeters in 24 hours, with a peak of rain of 61.8 millimeters in 1 hour. This disaster, it was really widely broadcasting in the international media. We received a lot of international help, humanitarian help, because of this disaster. And why? Well, as you can see, it was estimated that 300,000 people were affected by these landslides and floods. The World Bank estimated economical loss in damages near to 5 billion reais, billion with B. And very sadly, we had near to 1,000 fatalities. And until today, we have 345 people are still missing. Many cities was affected. I worked in this disaster too with Senacid team. Senacid was supporting the DRM. DRM is the Rio de Janeiro Geological Survey, where I work today. And just for example, Nova Friburgo, which is one of the most affected cities affected by this disaster, it was estimated that happened more than 5,000 landslides only in Nova Friburgo city. So it was really a really big disaster. And why I bring these two disasters? Because it's because of them, the policies that we have and the laws that we have at the time had to change. They were improved. It was created the National Civil Defense and Protection Policy. Alessandra spoke about this policy in her presentation, but I wanted to highlight 3 points here. First, the actions common to disaster risk management cycle are covered by this law. Prevention, mitigation, preparation, response, and recovery actions. Second, it's very clear in this law that different areas of knowledge must work in an integrated way, including geology and, of course, engineering geology as well. And the last point that I want to highlight is it's very clear also that the 3 levels of public power that we have in Brazil, republic level, state level, and county level, must work together, and one supporting the other one. This was and still is very important for us here in Brazil. And to cover all these actions from disaster risk management cycle, it was created the National Plan for Risk Management and Response to Natural Disasters. And it was defined 4 priority lines of actions. And the 3 main agencies that are responsible for these actions are the SENADI, which is the National Center for Risk and Disaster Management, the SEMADEM, which is the National Center for Monitoring and Alerting of Natural Disasters, and CPRM, that is the Brazilian Geological Survey. All these 3 agents are in the federal level. And CPRM are responsible for the mapping actions. And why I'm saying all these? In the map on the left, we can see a concentration of landslide occurrence that we have in Brazil. Because of geology, rain, and urban occupation, we have a concentration in some states. And in São Paulo state, we have 2 agencies that are responsible for risk management and carry out the landslide risk mapping. The one is the IPT, where Alessandra works, the Institute for Technological Research, and the other one is the Geological Institute, the IG. And in Rio de Janeiro state, here we have Rio de Janeiro with more than 70% of the occurrence of landslides. We have the DRM, the Rio de Janeiro Geological Survey, where I work. And for the rest of the states of Brazil, we have CPRM. CPRM are responsible for all the other states of Brazil. In this map on the right, it's a very recent information. The last update is from last month, May 25. We have the information that 1,600 109 counties were mapped by landslide, were mapped by CPRM, a landslide risk mapping. This is a very good number for us because it is a huge country. And about this methodology, about the landslide risk mapping methodology, what is the goal? What is the objective? Well, identify, describe, assess, and delimit areas subject to the occurrence of geological geotechnical process. And as we will see, many of these processes have a huge contribution, anthropogenic contribution in them, to them. The target areas are steep slopes, mainly those that have been occupied, and the scale must be a very good one. Usually we work with 1 to 1,000 or 1 to 2,000. I divide the methodology in 3 major groups: the actions that we do before the fieldwork, the actions at fieldwork stage itself, and actions after that we have to do after the fieldwork. Well, as you can see, first we have to establish a contact and do a partnership with the civil defense, the county civil defense. We do a pre-field analysis with all the available data that we have, such as we analyze the inventory of occurrence, satellite images, previous mapping, previous work, previous academic works, anything that are available for us. And usually we do a technical meeting with the municipality where we explain all the methodology, we will explain what we will do in their county and the products that we will generate. I brought here just 2 examples of pre-field analysis using satellite images. On the photo on the left, we have a feature that was observed in the satellite image, and the same feature in the other photo observed in the field work. It's a big gully, right? So just our example, the other one, a feature that was observed in satellite image, the same one observed in situ, in loco. A very high slope, and the slope is very too close to the houses in the bottom. Just an example to illustrate what I'm talking about. And we have the fieldwork stage. The fieldwork itself, I will explain better in the next slide, but we do the fieldwork. We have oblique aerophotographs, and we use it to take them from helicopter flights, but nowadays are more common use drones for that. And after all these, we do the assessment and we delimit the sectors of risk. And what we do in fieldwork? First, we have to locate the evaluate sites, locate and describe all the area. We identify and describe the existing or the potential anthropogenic geological geotechnical process. We identify how many houses are threatening or could be affected by this process that we identified before. We consider the vulnerability of the urban settlements as well. And after all these, we do a list of recommendations of alternative measures that can mitigate these risks that we identify in the field. And at the end, as I said before, we delimit the risk sectors and indicate the degree of landslide risk in this area. All this data that we collect in the field work, we put on a kind of field record. I brought here at the bottom an example from that we use at DRM. All this information we put there to record and we'll use in the next step. And what we search in the field, what we look for? Basically, evidence that the ground is unstable. We search for cracks in the ground, cracks in the walls, leaning or overturned trees and walls. We search for scars from past landslides. Usually they are hidden by new vegetation, but we have to have a clinical eye to search them and find at the field. And in many cases, sadly, we find anthropogenic interventions in a negative. This intervention contributes in a negative way to the risks. We see a lot slope cuts, very high or very steep slope cuts, or they are very too close of the houses. We see a lot also water and seawater discharge. We see leaking water from broken pipes. We see that a lot here in Brazil. Garbage dumps, inadequate garbage deposits, and all these contribute in a negative way to the risk assessment, of course. And after all these stages, and all this information that we collect on field work, we have to put all this data in a GIS environment, the Geographical Information System environment, and we feed the geodatabase. And then we prepare the final products, reports, maps, forms, boards, anything that is needed to deliver to the municipality. And usually, when we deliver these products to the county, we do a technical meeting again, but it's where we explain to the users, to the decision makers, how they can use better, how they can use each product that we are delivering to them. This is an example that happened in DRM. And I brought here 4 examples of the 4 most important and non-mapping agents that we have in Brazil. The first one, it is from CPRM, the Brazilian Geological Survey. And I wanted to highlight here 3 points. First is that they work with 2 degrees of landslide risk. High and very high, R3 and R4 that I'm showing here. Second, they produce a kind of risk board here on the right. It's where they summarize all the important and relevant information about the area. Have the process description, how many houses are threatening, the recommendation that they made to mitigate the risk in this point. Everything that is relevant is summarized in this risk board. And the third point that I want to say, beyond the reports, the regular reports that we generate in this mapping, the CPRM produce a specific form to deliver to CEMADEM. CEMADEM, as I said before, is the National Center for Monitoring and Alert of Natural Disasters. And this is very interesting and important because all the mapping, landslide risk mapping that CPRM do, they inform to CEMADEM, they feed the CEMADEM database, and this is very important to risk management as a whole in Brazil. Very nice. The other example is from IPT, where Alessandro works. Well, the IPT team identify on the field 4 degrees of risks, low, medium, high, and very high. But for the first 2, low and medium. They identify on the field, but they classify as monitoring sectors. And for the other two, high and very high, in this specific example that I brought here, it is they detail more the structural measure that they recommended. The engineering works are more detailed and making these products a more complete product. It is really helpful for the decision maker with more detail to the municipality. It's a very good product and more really completed. The other example from São Paulo State, it is from the Geological Institute. These products here are very recent. They made this region last year. It's very interesting because they work with 4 degrees of landslide risk, low, medium, high, and very high. And it is very interesting because they combine the methodologies. They combine all these methodologies that I explained here, the landslide risk methodology, with other information, such as hazard maps, potential damage maps, and vulnerability maps. They combine all this information and produce a final landslide risk map, as I'm showing here on the right. And one thing that I consider very nice, very cool, is that their field records are very detailed. So I'm showing here at the bottom. This is very nice. And for the last but not the least, I bring here an example from the RM where I work. So I do this kind of thing too. Well, we work with 5 degrees of landslide risk, low, medium, high, very high, and imminent risk. And what is this? Remember that evidence that I showed before that shows the ground is unstable? There is sometimes when we are in the field work, they are so many or they are so bad that we classify the area as imminent risk. We highlighted the point in a purple color because they some areas are really different. They are very, very, very bad, a very bad situation. We produce a risk board tool similar to CPRM, where we summarize all the relevant information. We put the process, the description of the process, how many houses, the list of recommendations that we do to mitigate the risk in this point. We put some photos, a draft of the evaluated site. We produce as well report maps of field records, and we do a table where we rank all the evaluated sites from the most critical one to the less critical one. This is really helpful for the decision maker of the county. It helps him to where they have to look first, to act first in their stage. As final considerations, it is clear that it is a qualitative and subjective methodology. Depends a lot on the experience of the specialists, especially in the field work. But the classification is in constant evolution. New technologies are being incorporated as they are being created, of course, such as the use of drones, the use of GIS environments, and other kinds of technologies. We have many difficulties, sometimes technical, sometimes technical ones, sometimes social, human, money, political. So all these difficulties pose a great challenge for us to carry out this mapping, this landslide risk mapping, but it's our reality, so we have to deal with this. This is my personal opinion. I think that the work does not end when we deliver the product. I think that us as geoscientists, us as geologists, our work will be done when these products that we generate are really used and they provide a positive change in the society. When we get these, when we got these, well, now, okay, our job is done. And for that, we have to learn how to work with different areas of knowledge. We have to learn how to work with social scientists, with politicians, tough issue, and geographers, engineers, who have to learn how to work with different areas. And that's why I write this. There is still so much to be done. Well, I want to say thanks again to the International Association of Engineering Geology, to the Youth Committee, and I want to say thanks to Strat as well. I want to say thanks also to the Brazilian Association of Engineering Geology and to the young group of the Brazilian Association. I'm very grateful to be here today sharing this topic with you guys. Thank you very much.
Thank you very much, Ms. Freitas. It was a really interesting topic, following another interesting topic from Professor Corsey. I think it's time to go to some questions. Let's go to the first one. What happens after a neighborhood was classified as high risk? What are the next actions?
Well, when we classify an area, high, very high, or imminent risks, this stage is up to the municipality. Sometimes they they accept our recommendation and do the engineering works. Sometimes people are replaced to another place, to another neighborhood. Depends a lot of the economic issue, the political issues, depends a lot of many things that are out of our hands.
Let me ask a question. How easy is in Brazil to convince those people that are in high risk areas to move to another area?
It's not easy. We have to change our culture, because as you saw in the presentation, it's a very old issue here. So we have to change this culture to this disorderly occupation, urban occupation that happens here. We have in DRM, we have some actions that we work with school, with kids, that we teach to him how to not occupy these areas, and how they can identify, even being a little one, how they can identify these risks. And well, we try to change this culture from the little ones.
I understand. I fully understand that, because it's very similar also to Greece, that we have some, let's say, risk maps, and still some urban planning is not appropriate.
Yes.
We always know.
It's not exclusive.
Exactly. I can't see any other question from now. I think we're almost ready to end up our session. It was really nice to have both ladies here from Brazil. It was an honor to have you both as presenters during our e-YEG webinars. I hope to meet you somewhere in one of the IEG's conferences in the future. It will be really nice also to network through our e-YEG actions. I would like to let you know that more webinars will come for the future, our monthly event, and many more actions through our e-YEG network will be diffused. Once again, I would like to thank you, Professor Corsi and Ms. Freitas, for being here today. It was our honor. I would like to thank all of you, all the attendees, for being here. I don't know if you have some last words, Professor Corsi or Ms. Freitas, to say.
Thank you. I want to, sorry, I will start. I am very glad to be here and sharing all this information, sharing the Brazilian experience. I want to say thank you very much to you, Strats, for all your patience and all your kindness. Thank you very much. And thank you for everybody that are watching us now.
It was an honor to have you here.